In this example, we're being asked to show that a specific function we're given has a 0. So that would be a y value of 0, that y equals 0 at some point between x equals -2 and x equals 2. Notice that they are not asking you at what x value does it happen. Where would I plug, what x would I plug in to get out a y value of 0? They're just asking you to show that someplace in between these two given numbers here, there's going to be a 0. Well, anytime you run into that situation, this is really going to come back to the intermediate value theorem, the IVT. Usually this happens when they want you to they don't care what the x value is, they just want you to show that there is some x value that exists. So when you go to use the intermediate value theorem, the first thing you've got to do is show that you can use it. The first thing that you have to do to show them that you can use the intermediate value theorem is you got to tell them that it's continuous, or show them that it's continuous on the given x interval. So our x interval on this one is between x equals -2 and x equals 2. So kind of step one of the process is you would say, well, the function that you all gave me to start with, this f of x right here, f of x is a polynomial, right? It's an equation that just has a bunch of ax squared plus bx plus c type of setup going on. There's no fractions or anything like it. So it is a polynomial, and all polynomials, they're continuous on an interval, and specifically they're continuous on the interval -2 to 2. There's no place where math would break on that, so you can tell them that this graph is continuous from x equals -2 to x equals 2. So you've started off by showing that our graph is continuous on the interval. Then from there, what you got to do is you basically see that where the endpoints of your interval, what the y values are there. So for me, what I would do is I'd come in and I would say, okay, I want to know what does f of -2 equal, my left endpoint, and what does f of 2 equal, my right endpoint of my interval. So we're plugging those into the equation that they gave us up top here. So we get that f of -2 would equal -2 to the third minus -2 minus 1. So then out of there, we are going to get what's that going to be? -8 plus 2 is -6 minus 1 is going to get us -7. So that is a y value right there. And then we go find where the thing ends on the other side. So at f of 2, we get 2 to the third minus 2 minus 1. And so out of here, we're going to get f of 2 is equal to 8 minus 2 is 6 minus 1 is going to get us 5. So f of 2 equals 5. And so the cool thing about the intermediate value theorem is it says because our graph is continuous right now, that if I start over here at -2, at x equals -2, I know that I'm going to get out a point of -7. So at x equals 2, I get the dot at -7. I then get over on the right-hand side of my interval, I know that at 2, I get out the y value of 5. And so what the intermediate value theorem tells us is that the only way that we can get from this dot over here to this dot over there without lifting our pencil, because the graph is continuous, is if we get every value in between -7 and 5. You're guaranteed that you get every value between -7 and 5 at least once. Well, what value do we really care about here? We care about y equals 0. Well, guess what? Y equals 0 is in between -7 and 5. So the only way to get from one side to the other, no matter how you draw that graph, is if you go through 0. So you can say now, by the intermediate value theorem, you know that at some x value, they don't care where, remember, they just care that it's at some x value, the y value, f of x, has to equal 0. It has to equal a lot of things. It has to equal -6. It has to equal 4. But specifically in this problem, they wanted us to show that it had to equal 0 at some point in between there. And by the intermediate value theorem, we've shown that. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.